Hello once again, I am Jim Dukart with T&D How Videos. Tonight we are in Boston, Massachusetts at Eversource Energy. We are going to be watching a process called stray voltage sniffing. Our participating utility is Eversource Energy, and this video is sponsored by Burns and McDonnell. Now what you are seeing here is an Eversource truck equipped with a stray voltage sniffing device on the back of the truck. You see that here on the back of the truck. Next, we go live to a street in Boston at about 2 o'clock in the morning where we see that stray voltage equipped truck driving down this street, sensing all of the streetlight posts to see if any stray voltage is coming from the underground wiring into the streetlights. Now here we are inside the truck. This is the screen that the driver and other crew member are watching to detect stray voltage spikes. And now you see it live. The street scene goes above and the red lines below show the voltage spikes, and now you're going to hear what it sounds like.
Oh, you think it's a spot, and it's just, as we get past the overhead now, right, you'll see it will drop back down.
Now, as our driver Brian explained, that sound came from overhead equipment, so it's not something this crew needs to look at tonight. But now I'm going to let Brian and James, his counterpart here, take it away in terms of describing what they're doing looking for stray voltage.
And we're looking for like it's a narrow, high spike usually. Alright, so now Jim, something like that is exactly what we're looking for, a high spike. So what we'll do in a case like that, we'll spin around and go by it again. Alright, so Jimmy, that's a real high spike right there. You see how high it is up there? First, see where the object is that we're getting the spike off of.
So now, Brian, we'll just back up and reposition the truck exactly where they sense that high spike.
Oh, that's a crazy high spike right there. So we're right on it here.
And so here's the view from outside the truck. Again, you see that sniffer on the back of the truck. You see how quiet the streets are at 2 a.m.
Jim, this is a tester. It picks up from 6 volts and higher. Like I said, we're just checking to see, what we might have been getting that off of. Oh, okay. So this isn't normally the concrete on this pole would not be energized. So at this point, Jim, we actually have to measure the voltage. It might only be 6 volts. It could be 120 volts. 79, 69 volts, 22, 30.
And now that Brian has detected the high voltage, he's going to open up the street light wiring to see what could be the problem.
Normally this ground isn't always connected. So, Jim, that return current should normally be going to the manhole. It's actually going to the base of the pole. The neutral's messed up, obviously. Hopefully, you disconnect this, and the stray voltage will go away. So, Jim, at this point, we know what the problem is, that the end star neutral's messed up. We'll make it safe for tonight. Put a tag on it.
Now, before he tags it and closes it up, I asked Brian to explain what the problem is with stray voltage.
Jim, unless a customer was to touch on it, maybe he's standing on this, so he's you're grounded here, and now you're touching the pole, you could get shocked. Or this could be grounded, and you touch this to this, you could get shocked. You wouldn't know unless somebody got shocked, or if the stray voltage truck picked it up. It says, do not connect, bad neutral, 69 volts stray. So in case the city of Boston was to come by, they don't inadvertently reconnect it.
Now he'll close that streetlight post back up, test once more for stray voltage, and let's go back to the truck and listen to Brian.
Again, Jim, that was actually an easy one to troubleshoot because, we were able to pull the neutral up. Sometimes you have to actually test it. But like you said, Jim, you see the big spike is where we just were, so now we're driving past streetlights normally, and there's no spikes at all like that. It's just, we try to ride towards the side of the road. Like in a road, like a road this wide, we actually ride it both directions. Like if if there was stray voltage on the left-hand side of the street, I wouldn't necessarily, get a spike on this while I'm riding this. We put in a stray voltage form to our boss, and again on a case like the job we had tonight, we'll go back tomorrow night. We'll cut the service in the manhole, and we'll put in a regular trouble report. So if cutting rid of that light didn't get rid of the stray voltage, we would have had to stay there since it was over 20 volts, and I would have had to call a troubleshooter to come out and assist me, because we can't leave if it's over 20 volts. We're not allowed to leave it unguarded. If it's under 8 volts, it's company's discretion to fix it. 8 to 20 volts, we fix it within 24 hours, and if it's over 20 volts, we can't even leave it. Coned off isn't even sufficient. We actually physically guard it. We'll call for another crew if we have to, or a lot of times we actually call the city of Boston street lights if it's their lights. So we'll stand by until they'll get there. 6 days, yeah. Usually we find anywhere from 2 to maybe 8 things a week. Anywhere from 13 volts to 120 volts.
And with that, you have seen our T&D How video covering stray voltage sniffing as we watch our Eversource truck continue to patrol the streets of Boston looking for stray voltage. Once more, our participating utility was Eversource Energy. This video is sponsored by Burns and McDonnell. I am Jim Dukart with T&D How videos. Thank you for watching.